Good afternoon. Today I would like to talk to you about my PhD topic, which is the role of immunomodulatory strategies to improve outcomes in sepsis. My name is Júlia Hollósi, and I'm a fifth-year MD PhD student at Semmelweis University. My vision is standardized treatments for specific medical situations, and my mission is to delineate the best treatments and incorporate new technologies into care plans. I would like to do this through my specific goals, which are investigating the safety and effectiveness of intravenous immunoglobulin treatment versus blood purification, and investigating the safety and effectiveness of intravenous immunoglobulin therapy before and after the onset of septic shock. Let's start with my first project. So what's the problem? The problem is that sepsis is prevalent and deadly in the ICU. Around a third of patients in the ICU have sepsis, and unfortunately around 26% die. So what do we already know? We know that intravenous immunoglobulins and blood purification treatments, such as plasmapheresis and hemadsorption, may improve outcomes. A recent study suggested that plasma exchange and polymyxin B hemoperfusion may reduce mortality. So what's missing? There's no clear evidence on patient-specific outcomes, such as organ dysfunction. The data is inconsistent, and the guidelines are indecisive. Therefore, our aim is to investigate which treatment has the most beneficial effects on organ dysfunction in sepsis. Let's go into some more detail about these treatments. In sepsis, there's a dysregulated host immune response to bacterial endotoxins, which leads to a cytokine storm and an immunoglobulin deficiency due to increased consumption and decreased production of immunoglobulins. This then leads to septic shock. You can do polymyxin B adsorption, which is a blood purification method which removes the gram-negative endotoxins from the blood and therefore helps to cease this hyperinflammatory reaction. Similarly, plasmapheresis involves the removal of coagulation factors, immunoglobulins, cytokines, and toxins. And hemadsorption involves the removal of cytokines and toxins. However, this doesn't do anything about the immunoglobulin deficiency. Therefore, there's a theory that if you add intravenous immunoglobulins, it will help the patient's own immune systems clear pathogens and toxins and interact with the innate immune system. Our clinical question is which immunomodulatory therapy ranks the best in improving organ function in patients, septic patients. So our population is septic patients. Our interventions are IVIG treatment, plasmapheresis, hemadsorption, and polymyxin B adsorption. Our comparator is standard therapy, and our outcomes are organ dysfunction via SOFA score and mortality. Our hypothesis is that immunomodulatory therapies are superior to standard therapy in improving organ function in septic ICU patients. The clinical implication of our study is that we would like to improve organ dysfunction and damage in septic patients. Here you can see our systematic search key, which was done in 3 databases, PubMed, Embase, and Cochrane. The first domain refers to the population, the second to the interventions, and the third to the type of trials that we will be including, which are all randomized control trials. Here you can see we began with nearly 4,000 records, and after duplicate removal, we ended up with nearly 3,000. We have just very recently finished title abstract selection, so we will be moving to full text selection shortly. Let's move on to my second topic, which is about investigating the safety and effectiveness of intravenous immunoglobulin therapy before and after the onset of septic shock. So what is sepsis, really? Sepsis is a life-threatening organ dysfunction caused by a dysregulated host response to infection. This leads to, as previously discussed, an increased consumption and decreased production of immunoglobulins, which then leads to immunoparalysis. Septic shock is the last stage of sepsis with profound circulatory and cellular abnormalities which require vasopressor therapy after adequate fluid resuscitation. So at this point, there's a complete dysregulation of the systems, and it's very difficult to reverse. As we discussed, there's a prevalence of around 30% of patients in the ICU who have sepsis, and around 10% of these progress to septic shock. This is a very big problem because the mortality of septic shock is around 46%. So IVIG therapy could potentially replenish depleted immunoglobulin stores, which is also significant in septic shock because this depletion happens even faster. There is potential for this kind of treatment, as a recent meta-analysis showed a relative mortality rate of 0.86 when using IVIG in septic adults, which they found to be clinically and statistically significant. However, the evidence is unclear on the best way to use it. It's not really clear what kind of dosage to use, when to give it before or after septic shock develops, and what kinds to give as well. Also, improper use leads to wasting, which is a very big problem because IVIG is a very rare resource. It's very expensive, it's not very available, and so the cost-benefit ratio of using it is unclear. Our clinical question is IVIG treatment for sepsis more effective before or after the onset of septic shock? Our population is septic patients, and our interventions are IVIG treatment before and after the onset of septic shock. Our comparator is standard medical therapy without IVIG treatment, and our outcomes are organ dysfunction and mortality. Our hypothesis is that IVIG treatment is more effective in patients who receive it before the onset of septic shock. The clinical implication of our study is that we would like to improve patient survival and optimize resource management. As you can see, we have some key articles. Here you can see that we found some key articles in which patients were first stratified into shock and non-shock groups and then randomized to either an infusion or of IVIG or a placebo. And here you can see that there were also some studies which the patients all had septic shock and then were given either IVIG treatment or placebo. So the caveat to this situation is that it's not so clear what the definition of sepsis is based on just these studies, because as you saw, some of the studies were from the 1990s, others were from the 2010s. So clearly there's a very wide range of articles that we are looking to include here. However, the definition of sepsis has been redefined several times. The first time the Sepsis 1 guidelines were made in 1991 when it was based on a systemic inflammatory response syndrome plus an infection. And in this case, there were 3 categories: sepsis, severe sepsis, and septic shock. In 2001, the guidelines were revised to the Sepsis 2 guidelines and the Sepsis 2 definition, and there was more detail included on what these guidelines should include. And then in 2016, they were once again revised to the Sepsis 3 guidelines, which is now based on the sequential organ failure assessment. And as you can see in the chart, there is now only 2 categories, which are sepsis and septic shock. So it's not so easy to compare articles from the 1990s to the articles from, for example, 2015, 2016, 2017. So to overcome this obstacle, we would like to do a subgroup analysis to make sure that we are comparing the correct levels with each other. In summary, I would like to be finished with these projects in the autumn of next year. And I would like to leave you with a quote that really emphasizes how rare but also how valuable IVIG treatment is, which is that no one thinks about how much blood it costs. Thank you for your attention.
I saw that your first key article was published in '98, 25 years ago, more than 25 years ago. So why do you think they were unable to prove the efficacy of immunoglobulin? Is it because of the timing, or because of the dosage, or something else? What's your opinion?
I think there's a very wide range of treatments that they're giving, like the amount of dose that they're giving, also the type of immunoglobulin that they've been giving has also changed, and it's very hard to compare these, because to give one type of immunoglobulin is not necessarily the same as a different, or to give it much later in the treatment is not necessarily the same as much earlier. So I think there's just such a wide range of all of the randomized controlled trials right now that there's not really a clear answer.
How much % of this kind of patients has decreased immunoglobulin level?
Oh, like of the, yeah. I don't know the exact %, I'm sorry, but I remember that I was reading an article and it was quite high, like most of them.
You mentioned that in a response to Akor's question, that the type of the immunoglobulin, and this is a major issue, I think, in which country, in which population was the blood harvested from which the immunoglobulin was produced. Do you know anything about I remember we had a patient with a West Nile virus, and several years ago I read an article that, for example, in Israeli population, the West Nile titer, the anti-West Nile virus titer is very high because they have a lot of mosquitoes that carry this virus. So do you have any idea about the type of country-wise, the type of immunoglobulin?
No.
But understand my not question.
Yeah, I
understand,
really but
comment.
I think for most countries, like you get immunoglobulins from people in your own country, so there's a basis for that. Like you also have the same blood types and.
Yeah.
You're a fifth-year medical student and an MD PhD student with us. I'm very curious about what kind of challenges you face as an MD PhD student with us. I think this could be very inspiring and motivating for others.
I think the biggest challenge is scheduling things, scheduling the classes, scheduling the meetings, because everyone has work hours at the same time. So, you know, you can only miss 10% of your attendance in class. But yeah, but in general, if you ask your professors, they're very nice and they let you make it up on like the weekends or something. So it's fine.